Okay, now we have to investigate that what happened during transmission data that error occur, and how can we reduce this error. For investigating this topic, we need to calculate the data rate. What is the data rate? How can we compute it? We can say that data rate measures the amount of data a source generates in 1 second. Amount of data that a source generates in 1 second. Now, if we suppose that the source symbol rate is equal to the number of symbols that the source produced every second with the R. And if I suppose that, for example, a source produces 10 symbols per second, it means that R is equal to 10 symbols per second. So, in the previous chapter, we learned that the entropy of source that indicates the number of bits that are needed to represent a symbol. What was the entropy of source? The source entropy indicates and determine the number of bits that can be represented one symbol. Now, if a source has m symbols, the entropy is equal to log 2m. It means that the entropy will be log 2m bits per symbol. R is number of symbols per second for each source. Entropy is number of bits per symbol. Now, if I multiply these two values with together, R and entropy, I can find the data rate of the source, or source data rate. ds is the data rate of the source, which is equal to R times log 2 of m. And the unit of data rate is bit per second. Bit per second. This value is number of bits, number of data that each source produces. Okay, let's give an example. Suppose that the microphone of your smartphone converts your speech into a waveform. And the maximum frequency of this signal, suppose that your microphone of a smartphone produces a waveform in an analog form. The maximum frequency for example is 3.5 kilohertz. Now, what can I do that? How can I send this analog signal? We have to, for converting analog to digital, we have to sample this waveform. Now, we sample it using sample rate fs 8 kilohertz. Can I sample this signal with this frequency rate? According to the Nyquist criterion, my fs have to be greater than 2f max, because 8 kilohertz is greater than 2 times 3.5. 8 is greater than 7. I can do that. So each sample, look at here, each sample is a symbol for our source. Each sample is my symbols. It means that my R is 8,000 symbol per second. 8 kilohertz is equal to 8,000 hertz, and each sample is my symbol. Now, if my ADC, after sampling, I have to quantize. If my ADC quantize each bit using each sample using 8 bits, it means that my ADC has 2 to the power of 8, which is equal to 256 different symbols. ADC can produce 256 symbols. So the entropy of this source is equal to log 2m is equal to log 256, which is equal to 8. Now I want to calculate the data rate. I say that R times entropy 8,000 times 8 is equal to 64,000 BPS. We need to have information about the capacity of channel, that we will transmit our data signal with the data rate. For example, with the data rate 64,000 BPS, because the capacity of channel is so important for us and will affect our data transmission. The capacity of channel will affect our data transmission. In fact, the channel capacity measures the number of bits per second that can be transmitted over a channel. But the quality of a channel depends on two parameters. The first one is bandwidth, and the second one is signal to noise ratio, as you see here. 2-factor will affect our quality of channel. What is the bandwidth? The bandwidth is the frequency range from the low frequency limits to the high frequency limits. From low frequency, there is the range from low frequency to the high frequency limits that the data transmission signal can occupy with. We call low frequency as FL and high frequency as FH. So we define B, our bandwidth, with FH minus FL, the difference between the high frequency and low frequency. Now, as this bandwidth increases, it takes less time to transmit data. Suppose that this bandwidth is like an street. Suppose that this is the street. This is FL and this is the FH. And this range is my bandwidth, which is equal to FH minus FL. Okay? If the difference between the low frequency and high frequency increases, it means that my bandwidth is also increased. So what happened? I can transmit more data here than these bandwidths. It means that as B increases, it takes less time to transmit data because the value of transmit bandwidth is high. The second parameter and factor that affect the channel capacity is SNR, that we talked about that in the previous chapter. And we learned that the SNR is the ratio of the energy of signal to noise and the channel measured by its variance. We know that the noise is measured by its variance. So we know that noise on the channel limits the amount of data that can be transmitted over the channel. So, using Shannon-Hartley theorem, we can compute the channel capacity using Shannon and Hartley. Actually, these two scientific men developed this formula, Shannon and Hartley. And this theorem is called Shannon-Hartley theorem. Using this formula, we can compute the capacity of channel that we want to transmit our data through it, and is called C is equal to B the bandwidth of channel multiplying by log 2 of 1 plus SNR. Signal to noise ratio of my data, and also the bandwidth of channel. And we know that the formula of SNR is entropy divided by variance of noise. So suppose that my lower frequency is 0. It means that our bandwidth will be equal to FH, because bandwidth is FH minus FL. If FL is equal to 0, it means that my bandwidth is equal to high frequency, FH. Now, if I assume that my signal consists of 2 periods of a sinusoidal waveforms, that the frequency of this waveform is equal to FH. So if FH is 2 kilohertz, it means that my bandwidth is also 2 kilohertz. What does it mean? It means that we have 2 period data signal at the 1 millisecond. Look at here. It means that if my frequency of data is equal to 2, it means that 1 millisecond. F is 2 kilohertz. It means that I have 2 frequencies at 1 millisecond. So, because my bandwidth is also equal to FH, if 2 kilohertz, look at here, I can only send one data signal, because the bandwidth is 2 kilohertz and my signal frequency is also equal to 2 kilohertz. Now, if I suppose that my F of signal is 2 kilohertz and my bandwidth is 8 kilohertz, now I can send 4 data signal, data waveform at these bandwidths. 1, 2, 3, 4. Why? Because the bandwidth, my bandwidth here is 8 kilohertz. This is the effect of bandwidth on channel capacity. Now, for a practical data, for transmitting the practical data, we can say that a practical data transmission system, the channel must transmit all the data that is produced by the source. I have to transmit all of the produced data by the channel. So it means that the channel capacity is C. The channel capacity must be greater than or at least equal to the source data rate.